One of the most common things you'll encounter in data analysis for chemistry is the question of, are two values that I measure actually different because of the chemical phenomenon that's occurring? Or is their difference explained simply because of random error in the measurements? And so the example we have here for this worked example is we had 5 groups measure the density of ethanol. So they're all measuring the same ethanol, but they're all getting very different answers. And so this bold value at the bottom is the average. And if we look just at groups 4 and 5, we ask the question, is this 0.69 actually different than 0.88 with statistical significance, meaning that it's outside of the difference that would simply be explained by random error? We need to conduct this thing called a t-test. So this video is going to walk you through how to conduct a t-test to answer this very question for comparing the averages for groups 4 and 5 using Excel. The premise of a t-test is based on the idea that random error will always cause measurements to fit this bell curve or normal distribution. And so this distribution just shows the probability of an event occurring, where right in the middle where we have 0, this is what the average should be if we were to measure an infinite number of those measurements. Here we're only measuring this 4 times for each group. And then what we're going to do in a t-test is compute a t-score or a calculated t-value, and we're going to compare that to what we would expect the t-value to be if we just accounted for the random error of the universe. And so we'll do that really quickly. So to do that, we're going to go to Data here. And then we're going to go all the way over to the right to this Analyze section and then click Data Analysis. If you don't have this present, follow the linked videos in the handout that show you how to add this. This is a plug-in to Excel, but the adding process is different depending on whether you're using Windows environment or Mac. So we'll assume you already did that. Click the Data Analysis, and then I'm going to scroll down to the test that I want to do. You can see there's 3 t-tests, and I'm going to select this middle one, t-test 2 sample assuming equal variance, and click OK. And now, under the input range, I'm going to select the 2 sets of data I want to compare. So with the t-test, you're only ever comparing 2 things together, 2 averages. And so I am specifically interested in comparing the average from group 4 to the average in group 5. And so I'm going to go over and select group 4 for this input, and then I'll select group 5. It turns out that it doesn't matter which set of data you input first. It will just change the sign of the t value or t-score that we compute. Everything else we can leave default. Select output range here under where you want to put this computed data, and I'm just going to select this region here, and you just need to select a block of cells where it's going to dump the computed t data, and you'll see that here shortly. So I'll click OK. You can see it's dumping all of these values. So what do all these things mean? So you can see that I have variable 1 and variable 2. Variable 1 was the thing I input first, which is really group 4, and I'm just going to put that there. You don't have to type this. This is just for us to be on the same page here. So I'm comparing group 4 and 5. You can see it's computing the mean, variance. It's telling me the number of observations, 4 for each, which makes sense because we have 4 measurements going into that. It's computing this thing called degrees of freedom, which really isn't important. The main thing that's important that we're actually comparing is this computed t-value. So this is the thing that we're actually measuring or computing. And then we have this two-tail t-critical. And these are the 2 values that we're measuring. So the t-critical two-tail is the actual value on this normal distribution. So what I've done here is actually put these red lines on top of this normal distribution to simulate where that critical value is. And what that really means for us physically is that any computed t-value, the t-statistic here that we computed, if that value falls within this range, which I'm using as the plus or minus of this version, 2.44. So I put a bar here at minus 2.44 and a bar here at plus 2.44. If our value falls inside of this range, then we can say that the difference between those averages is accounted simply based on the random error distribution we'd expect for that experiment. In other words, if the absolute value of our computed t-statistic falls outside, out in the tails, in either direction of this distribution, then we can say that these are truly statistically different, and that their difference cannot be accounted for simply by random error, which means that they're different because of something about the experiment or the nature of the chemistry. So in this particular case, the absolute value, this minus 13.654, that's way out here in space, right? And so that's saying that the chance of these two things being this different is exceedingly rare. And it certainly can't be accounted for just based on random error. And so we would draw a conclusion that says that group 4 and group 5, the average or mean values of their ethanol density are different with statistical significance.